So good day everyone and good day to you sir. We are the group 1 or the Megaminds and we are here to present nuclear power plants or all you need to know about nuclear power plant. So the topic outline or the content of our report. So the first one is introduction, second is history and development, the third one is how does the NPP work or the nuclear power plant work. Number 4 is parts and functions of nuclear power plant. 5 is advantages and disadvantages. 6 is Bataan nuclear power plant and 7 is mechanical engineer's role in the nuclear power plant. So the introduction, NPP or also known as the nuclear power plants heat water to produce steam. On September 3rd, 1948, electricity was generated by a nuclear reactor for the first time at X-10 graphite reactor in Oak Ridge, Tennessee, US, which was the first nuclear power station to power a light bulb. On June 27, 1954, the world's first nuclear power station to generate electricity for a power grid. The Obnis nuclear power plant started operations in Obnis in the Soviet Union. Mostly nuclear power plants operate between 20 to 40 years. Aging is defined as continuing time-dependent degradation of material due to service conditions, including normal operation and transient conditions. Next is the history and development.
History and development. Radioactivity. Physicists discovered that uranium emits a bright rays without light, then other elements also exhibit same behavior, which they called radioactivity. Nuclear fission. Scientists discovered fission where atoms can be split into two by bombarding uranium atom by a neutron causing a chain reaction which makes large amount of energy. In World War II, research and application of nuclear fission led to the creation of atomic bombs used against Japan, uranium in Hiroshima and plutonium in Nagasaki. Cold War. Arms race between USA and USSR caused the rise of research for the application of nuclear power in bombs and electricity, which caused the building of nuclear power plants. Oil crisis. Price of oils in 1973. Economies relying in black gold look for other sources, thus nuclear power plants are being built around the world, specifically in India and Japan. And Chernobyl. Due to human error, the 1986 nuclear power plant in Chernobyl explodes, which led to the opposition making a break on the development of the industry. In Fukushima, the 2011 earthquake, accompanied with tsunami, crashed the nuclear reactor in Fukushima. To explode in turn, Japan phased out its 39 nuclear reactors, followed by German announcing as well. The current situation, 10% of the world's electricity is nuclear, with 417 reactors and 46 under construction, 10 of which are in China to accommodate its increasing demands. And in the future, 35 countries are collaborating under the International Thermonuclear Reactor in France for research of building nuclear plants over the long term with little raw materials and radioactive waste.
So the next one is how does the NPT works or the nuclear power plant works? In a nutshell or in the fewest possible word, Nuclear power plant works first nuclear energy, then go to thermal energy, to kinetic, and kinetic to electricity. Nuclear energy. The fuel source uranium that processed into little ceramic pellets that pack a whole lot of energy. So uranium is like a food in the mura siya food sa nuclear power plant, uh, like fuel. Then gagmay-gagmay siya, like the fuel pellets are sealed into metal tubes. So you can see in the picture on the right side, there are fuel pellets and metal tubes, which are then welded together to form a fuel bundle. And then the fuel bundle are then inserted into a large tank called calandria, the heart of a nuclear reactor. So here in the right side of the PowerPoint, there is what we call calandria, or the heart of the reactor. Nuclear generating stations split the uranium atoms in a fuel in a process called fission. So fission is the splitting of energy, and the result is the release of tremendous amount of heat. Next. Thermal energy, or what we call heat energy. To unlock the heat energy in the uranium, you need what's called moderator. So moderator is substansya para mo slow down ang kaning process. Special type of water called heavy water is used as the moderator. So moderator, or what we called heavy water, 10% heavier than the ordinary water. Heavy water, also called the DTO or the deuterium. It surrounds fuel bundles and slows down neutrons, so they're more likely to hit and split the uranium atoms. Chain reaction of atom splitting assures there is a constant source of energy to hit the heavy water. The heavy water is circulated through the reactor in a closed system, delivering the heat to a set of boilers, where it turns ordinary water to high-pressure steam. The high-pressure steam made from ordinary water is transported through pipes to a large turbine, where it pushes the blades and turns the shaft connected to a large rotor in the generator, causing the rotor to spin. Then lastly is the kinetic energy to electricity. Kinetic energy, which is the motion, just like you see in the picture, there is a motion of there is the spinning rotor. This a large electromagnet that produce a rotating magnetic field. So motion, then going to electricity or energy. This field moves across coil copper, or what we call stator, producing electricity that is sent across transmission lines to homes and business throughout the province.
How a pressurized water reactor works. Parts and functions. Parts and functions of nuclear power plant. These are the components of a nuclear power plant of the most common type, the pressurized water reactor. Control rods. These are the reactor's control elements acting as neutron absorbents. It is used to control the neutron population and the reactor reactivity at all times, making it critical during its operation and subcritical during the stops. Fuel Fuel elements. It is the material in which use in fission reactions. It is used simultaneously as a source of energy and neutrons in order to maintain the chain reaction. Pressurizer is a component of the primary cooling circuit where the liquid and vapor stages are balanced in conditions of saturation so as to control the pressure. Reactor vessel, or what it's also called steel pressure vessel. It is a steel vessel that houses the nuclear reactor, the main component of the nuclear power plant where the fission chain reactor is produced. Its nucleus is composed of the fuel elements, the vapor generator or steam generator, part of the cooling system of pressurized water reactors where the high pressure primary coolant bringing heat from the reactor is used to make steam for the turbine, secondary unit. So before um, s- the containment building, it is a building that houses the reactor's cooling system as well as several auxiliary systems. It functions as shielding in normal operation and prevents the leakage of polluting products to its nearby surroundings. Condensator or condenser. It is a heat commuter composed by a set of tubes where cooling water circulates. The water vapor going inside the condensator from the turbine is liquefied. Next one is alternator or the generator. It is a device that produces electricity by converting mechanical rotation energy from the turbine into electricity. Next is turbine. It is a device that receives the water vapor from the vapor generators, whose energy is transformed via the paddles into mechanical rotation power. Then pump. It is used to pump water for it to use in producing steam and is also used to pump the cooling water onto the condenser. Cooling water is the same water that induces the fissions as a moderator, which now serves to extract the heat generated by the fission reaction from the uranium in the fuel. Cooling tower is a site that makes it possible to send out to the atmosphere part of the residual heat produced in the generation of electricity. It is used to cool down the water that circulates through the condenser and is part of the plant's auxiliary cooling circuit. And lastly, the transformer. This system increases the tension of the electricity produced in the alternator to minimize losses in its transport to the consumption points.
So advantages and disadvantages of nuclear power plants. So first advantage is it has low cost operation. So after the initial cost of construction, nuclear energy has the advantage of being one of the most cost effective energy solutions available. The cost to produce electricity from nuclear energy is much lower than the cost to produce energy from gas, coal, or oil, unless those resources are located near the power plant they supply. Nuclear energy also has the added benefit of facing comparatively low risk for cost inflation, unlike traditional fossil fuels that regularly fluctuate in price. So, in short, nuclear power plants has much lower cost because um, it is much more efficient and much more cheaper to harness than those of from coal or gas. So next advantage is reliable source of energy. While some energy sources are dependent upon weather conditions like solar and wind power, nuclear energy has no such constraints. It doesn't matter if the wind isn't blowing or if the day is cloudy. Nuclear power plants are essentially unaffected by external climate factors and create predictable and steady energy output. A nuclear power plant in full swing operation can produce energy nonstop for an entire year, which allows for a good return or investment because there is no delay in energy production. So nuclear power plants are very reliable because unlike with wind energy, which is dependent on the climate or whichever location it is, the nuclear power plant is much more reliable because the power that you can harness is consistent and it is nonstop. Next. Um, so third advantage, it can last by years. Most nuclear power plants have operating lifetimes of between 20 and 40 years. Aging is defined as a continuing time-dependent degradation of material due to service conditions, including normal operation and transient conditions. So there's still a limit of what a how many years a nuclear power plant can continue producing energy. But as you can see, 20 to 40 years, that is a very long time for producing a lot of energy. So it is very reliable to harness energy by means of using of nuclear power plants. Next is produces low pollution. The overall output of pollution from a nuclear power plant is quite low compared with energy production from fossil fuels. The current consumption of nuclear energy already reduces over 55 million metric tons of emissions every year. This reduction in greenhouse gases is a great indicator of how switching to nuclear energy can help reduce our effect on global climate change in the long run. So nuclear power plants is a much more greener way to harness energy. So with the use of nuclear power plants, we can be more conscious of climate change and we can reduce our carbon footprint. So next, disadvantages. So the first disadvantage is it produces radioactive waste. A major environmental concern related to nuclear power is the creation of radioactive waste, such as uranium mill tailings, spent or used reactor fuel, and other radioactive waste. These materials can remain radioactive and dangerous to human health for thousands of years. So the byproducts or the used up products of nuclear power plants is very dangerous to humans. So that's why they should not be they should be disposed of properly and not be in contact with humans. The next disadvantage is expensive to build. Despite being relatively inexpensive to operate, nuclear power plants are incredibly expensive to build, and the cost keeps rising. From 2002 to 2008, the estimated cost to build a nuclear power plant grew from two to $4 billion to $9 billion, and power plants often surpass their estimates during construction. So so as the years pass, the cost for producing nuclear power plants become expensive. That's normal because there is limited amounts of places or limited amount of materials or places that we can build nuclear power plants. Next is impact on the environment. Nuclear power plants have a greater impact on the environment than just the waste they produce. The mining and enrichment of uranium are not environmentally friendly processes. Open pit mining for uranium is safe for miners, but leaves behind radioactive particles, causes erosion, and even pollutes nearby sources of water. So the downsides of nuclear power plants is that it affects the environment because the materials that it uses is very dangerous to the environment, to humans, and it can greatly affect greatly affect the surroundings. So next, security threat. Nuclear power presents a unique threat to our national security because it is powered by nuclear energy. Terrorists might target nuclear power plants with the intention of creating a disaster, and the uranium used to produce the power can be turned into nuclear weapons if they end up in the wrong hands. For these reasons, security surrounding nuclear power materials and nuclear power plants is extremely important. So in short, if if nuclear power plants can be taken hostage by bad people, it can be very dangerous for the people around or just in general in which country they are in. Next is limited fuel supply. One of the most important considerations to keep in mind is that nuclear energy is dependent on uranium and thorium to produce energy. So these two materials are the ones that power the nuclear power plants, and it is very hard to find such materials, or it is very limited to come across these materials. Next is accidents. Accidents can happen adversely affecting people and the environment. So nuclear power plants are in general very dangerous to everyone that is near, or whichever country a nuclear power plant is, they are at potential danger due to the fact that it is just very dangerous. So that's all for an update. Next. So the major accidents of nuclear power plants. In 1986, Chernobyl. It is the only nuclear accident in the history of commercial nuclear power to have caused fatalities from radiation. Several factors, including reactor design issues, and a poor safety culture, led to failed safety tests that caused two explosions, a fire that lasted for over a week, and the release of a large amount of radioactive material. And next is Fukushima in 2011. The earthquake that caused tsunami flood that backup generators at the Fukushima Daiichi plant, which were meant to pump cooling water through the reactor, were destroyed. As a result, three cores largely melted over the following 3 days, and there were several hydrogen explosions, as well as the release of nuclear material in the environment. So these two are the two major accidents of of nuclear power plants, and they were very devastating in their times and affected a lot of people and just left a lot of people in trauma. So that's why other countries in the world are now more cautious of nuclear power plants. So that's all for advantages and disadvantages.
So let's move on to Bataan Nuclear Power Plant, meant to be the first NPP in the Philippines. Its location is Napot Point in Morong, Bataan. Its area is covered by 3.57 kilometers squared government reservation. It has been completed on 1987, created as a response to 1973 oil crisis. Its expectations was 1,200 megawatts, equal to three 400 megawatts coal-fired electricity generating plants. Next slide, please. So these are photos of the Bataan Nuclear Power Plant. As we can see, there are like officials inspecting the place, and there is also a photo of an aerial view of the actual power plant. Next slide, please. So, Bataan Nuclear Power Plant. Its construction began in 1976, but following the 1979 Three Mile Island accident in the US, it was stopped. Safety inquiry into the plant revealed over 4,000 defects. Among the issues raised was that it was built near a major geological fault line and close to the then dormant Mount Pinatubo. By 1984, at completion, it cost $2.3 billion. Marcos was thrown out of power in 1986 Chernobyl disaster was a consideration by Aquino administration to not operate the plant. And now, in 2020, President Duterte gave a great green light to pursue the development of civilian nuclear energy, or CNE, for power generation through the issuance of Executive Order 116, which includes studying the viability of nuclear energy. But learning from Germany, the impact of the Fukushima nuclear disaster has weakened public confidence towards nuclear energy, resulted in the decision of the government to permanently shut down 8 of its reactors and pledged to close the rest by 2022. So now let's move on to mechanical engineer's role and NPP. Thank you.
And the last topic of the nuclear power plant, mechanical engineering role, is the duties of mechanical engineer at a nuclear plant are pretty varied. It would range from solving minor problems like a valve, so continue, like a valve manufacturer that has changed the part numbers for a van itself. So continue, like the rule, it will range from solving minor problems like a valve manufacturer that has changed the part numbers of a bonnet cell, uh, the part of the nuclear plants. Someone has to confirm that the part with the numbers are the same as the old part. Like like if there is a particular part that needs to be changed, you need someone to confirm it. If the numbers in the parts is just the same as the old ones, then to quite major problems like needing to install a third emergency diesel generator and everything in between. Mechanical engineers also work within the operation of the power plant, like the testing of the ship's emergency generator is done every week by running it unloaded to check if it's start on battery mode. As a safety equipment gets tested every month, someone needs to watch the result for slow degradation over time. It's like a chart that you can see if there are changes in degradation over time, like the increases of rate, of the temperature, or plant, or some measurement uncertainties. Then last is, when working in nuclear power plant, mechanical engineer ensures that every component used, starting from the water source to the electricity distribution station, works in optional conditions to provide continuous power generation. That's all.
So that's all for our report about nuclear power plants, or all you need to know about nuclear power plants. That's all. Thank you. And thank you for listening. God bless you all.